Chapter 8, Index Models. Now this chapter presents a more general presentation of these factor models, and we've already been through the CAPM, so we've talked about a single factor model, a model that uses just a single thing to explain returns. That single factor was an index, and we used a market index, and so therefore it's the capital asset pricing model. And later we'll do multi-factor models, but the point of this chapter is to go back one chapter, and look a little bit more at some of the underlying math and principles and regression statistics. So what we're going to do is we're going to look at the regression statistics. We're going to look at the R squared and the adjusted R squared. We're going to look at the beta of a regression, and then we're going to look at the alpha of a regression, and then we'll talk about the t-statistics and the p-value. After that, we'll talk about the tracking error and information ratio, which are ways to assess the risk associated with the managed portfolio. So again, this chapter presents a more general presentation of factor models. Again, we've talked about a single factor model. There are multi-factor models. We'll get to those in chapter 10. A single factor model, if that factor is an index, it's an index model. And if it's the market index, then it's the CAPM. So here's the general form of a single factor regression model, and it's the return of some asset I or some portfolio, in which case we might use P, minus the risk-free. And this is the return at time 1 minus the return at time 1, the return at time 2 minus the return at time 2, which is why we have these dual subscripts. And we'll often drop this second subscript T when we're doing notation, but it's always there, equals alpha for this asset. And so there's a single alpha, even though there's going to be 60 different time periods, there's going to be a single alpha and a single beta. So note there's no subscript on this. The beta is going to be times the return of the market at time t, again with the risk-free at time t. And then for each of the data points, I'm also going to have this error term or this epsilon, and we'll see this when we get to the spreadsheet. So again, this is the general form, but we're going to make a quick switch in notation. We're going to let capital R equal the return minus the risk-free, which is going to equal the excess return or the risk premium. And so we can rewrite this equation with little ri minus little rf. We can just write it as big Ri, and we know that it really is the risk premium. We can do this for both the return of asset I and the return of the market. So here is our general form of our regression. And here's the idea. The return of the market for some time period, t, market risk premium for some time period, t, so we're just making the switch from little r to big R, is one of many possible factors that can explain asset or portfolio returns. And since returns are just changes in prices, we say that if a factor explains returns, it also explains the changes in price, and we say this is a priced factor. And one of the things that we're going to do in this chapter is look at the regression statistics to determine whether or not something really is a priced factor. Is it really telling us something about the returns of a stock or an asset? This is relatively easy for the market because the market does seem to pretty much, for many stocks and many portfolios, really tell us a lot about the returns. And so it's almost always the case that the market is a priced factor. But later we're going to get to other things using this same regression technique, and maybe they may not be price factors. Okay, so here's the general notation, and again, we'll get to this when we move on to the next chapter. We can represent the value of a priced factor at time t as ft. And so, for example, the price factor with the return of the market, or the market risk premium, we can actually write that as F, as some general factor. And a factor could be currency prices, or it could be energy prices, or it can be industrial production, or it could be some sort of amount of trade. There's many different things that we can put in as a factor. So far we've put in the return of the market, or the market premium, and that's what we'll continue to do. And then we want to figure out what this alpha and this beta are using an OLS regression. We also want to figure out whether these things are statistically significantly different from zero. Is there anything there? Is there really the case that this is actually explaining returns? And then the next thing we want to do is see exactly how much of the variation of the return of the asset or portfolio is actually explained by the factor. So it may be statistically significant, it just doesn't tell us very much, or it may tell us a lot. So our goal will be to examine regression statistics to determine three things. First, how much of the variation of returns of the asset or the portfolio are explained by the factor or factors. To do that, we'll look at the R squared and the adjusted R squared. We also want to know, is this factor really telling us something? Is it a priced factor? Does it explain returns? Does it explain the change in price? And to do that, we'll look at the value of the beta and we'll look at the p-value. And then the last thing we want to look at is, was there actually excess return? Meaning, after adjusting for the risk factor or risk factors, was there extra return? And we call this risk-adjusted excess return. And we're looking to determine if an asset or a portfolio beat the market on a risk-adjusted basis. And to do that, we look at the alpha and the p-value.